So right now I want to talk about a particular problem, and this is taken from Calc AB exam 2006, number 3. And this is a classic problem, a free response question problem, in the topic of analyzing functions. So I call it a function analysis type of problems. And sometimes they can come out in the form of a graph, or sometimes they can come up in the form of a chart. But in any case, you have to really think about, whenever you look at this problem, you have to think about the relationship between the function, its derivative, and also its integral. And often the tricky part here is that the one that they provide for you tends to be not the original function they want to analyze. They usually want you to analyze either the integral of this problem, of this function that is represented here, or the derivative of this function that is represented here. So let's take a look at this. Now we have a function, and clearly these are clearly marked, and there are straight lines between these dots. And let's take a look at here. Here, notice it says it's a graph F. Now, it's very important to note that, because let's take a look at the actual problem itself. Here it says the graph of the function F shown above consists of 6 line segments. 1, 2, 3, 4, 5, 6. Now here, this is where it becomes tricky. You let G. So that means they're not really asking much about the F, but they're asking about G. But there's a relationship between G and F. So here, G be the function given that G is the definite integral from 0 to some sort of x of the function f of t dt. So what that means is, I think this clearly, immediately you want to say, okay, what that means is that G basically is going to be a function that is determined by the area under the graph of f of t. Under the graph, right? Because it's a definite integral. Okay? So this is very, very important to know. So now, let's go to part A. Part A says, we want to find G of 4. And so, well, how do I find G of 4? Well, very straightforwardly, use the formula they give us in the beginning, which defines the relationship between G and F. Notice this graph is about F. You're looking for G. So here, following along, G of 4. So G of x now is G of 4 equal to integral 0 is 0, x now becomes 4, so it's from 0 to 4, f of t dt. Now remember, that just simply means the area under the f graph between 0 to 4. So now let's take a look at from 0 to 4. 0 to 4 basically consists of this area right here and this area right there. Right? So it consists of this area plus this area. Now we know that this area is a negative area. You have to be very careful because it's below the x-axis. So it's a negative area. And take a look at the area of this triangle. This is -2 down this way and +1 over this way. And area of the triangle, we all know that is 1/2 base times height. Base is 1, height is 2 times 1/2, you get -1, right? Plus the area of this trapezoid. Now this trapezoid, you remember the trapezoid, how we find the area of the trapezoid is you add the 2 bases, multiplied by the height, divided by 2. So 2 bases, so this is 1 right here, this is 3 here, so that's 4. Right? 1 plus 3 is 4. 4 times 2 divided by 2. So you get 4. So the answer is 3. So G of 4 is 3. Easy enough? Okay. Now, so what is G prime of 4? What G prime of 4? Well, if G is the integral of f of x, then G prime must be the integrand of the integral, which means G prime of 4 is f of 4. Now, f of 4 simply means what is the function f at x equal to 4. Well, take a look at this. This is the function of f at x equal to 4. The answer is 0. That's it. The answer is 0. What about G? Now we go to G double prime of 4. Now G double prime of 4, maybe if the logic holds, right? G of 4 is the integral, G prime is the f, G double prime then becomes G prime, right? It follows a very simple pattern. So G double prime of 4, according to f and according to the relationship between G and f, is that G double prime is f prime. Now f prime simply means the slope of f of x at x equal to 4. Right? Slope. Now let's take a look at the graph. Can we figure out the slope? At this point, what is the slope of the graph at this point? Well, we can take a look at the near region. This is a straight line, right? And this is a slope of, slope is rise over run. So rise in this case is -2, 1, 2, and over 1. So -2 over 1. So the answer is -2. So you have it. G of 4 is 3. G prime of 4 is 0. And G double prime of 4 is -2. Now, next, we're going to part B. Now, part B, let's take a look at this. Part B says, does G, now again, we're looking at the graph of f, but it is asking about for G. Does G have a relative minimum, relative maximum, or neither at x equal to 1? And you had to justify your answer. Now remember, every time we're talking about max or min, we are talking about first derivative test. So I'm going to use another sheet of paper right here and cover up the part A. So I have enough space to look at the graph and the solution. So part B, let's do part B. Alright, part B. Now I want to find out G. Again, this is about G, and we want to work on the first derivative test of G, which means G prime, and we are setting G prime equal to 0. Now remember, G prime is f. And so when setting G prime equal to 0, we're setting f equal to 0. Now let's take a look at the graph. Look at f graph. Where does it have 0 for f? Well, at x equal to, well here, we had -4 when f equals 0, when x equal to -1, when x equal to 1, and when x equal to 4. So we are doing this first derivative test. -4, -1, 1, and 4, and this is x. Now here, I guess you didn't see that. So I just did a little chart right here. This is the first derivative test chart. So these are the critical values for x. Now, these are the g prime. But notice g prime is equal to f. So I'm still looking at f, the value of the f function, not the derivative of the f function. Remember, the value of the f function is the derivative of g. A little confusing, but I'm sure you can sort it out. So now let's take a look at the graph. So I'm looking at the value. So anything less than -4, again, yes, I'm looking at the slope for the g, but I'm actually looking at the actual value of the f, because f is the derivative of g. So let's take a look at the value that's less than -4, so say -5. If you look at the graph of -5, at -5, the graph of f at -5, we got a negative value. So that means we got a negative value right here. Graph goes down for g. Okay, graph goes down for g. Between -4 and -1, let's pick, say, -3. So at -3, f is a positive value. So f is a positive value, so it goes up. Between -1 and 1, say, pick 0. And if we look at 0, we get a negative value. So bringing back up negative value. Graph goes down. Between 1 and 4, let's say take 2 for example, and at 2, f is equal to positive value for g prime, and anything less greater than 4, I say 5. 5 is a negative value, so going back negative value, it goes down. So the question here says, does g have a relative minimum, relative maximum, or neither at x equal to 1? And you take a look at the graph right here. Well, it seems that at x equal to 1, g has a relative minimum. Right? G has a relative minimum. And that's it. This is the answer. And this is the justification. And you're done with part B. Now, let's take a look at part C. And I'm going to get more piece of paper here. So let's take a look at part C. Part C is a little tricky and a little confusing, but no fear. We can get through this. Suppose f is defined for all real numbers x and is periodic with a period of length phi. So notice, what that means is that it will repeat every 5 units. So I will assume that it's going to continue to go like this and continue to go like this for every 5. That makes sense. So that means if we can understand what's going on of every 5 units, we can then project what will happen later on. The graph above shows 2 periods. Makes sense, 2 periods. Given that g of phi is 2. G of phi is 2. Find G10. Now, G of phi is 2. First of all, so this is part C. First of all, they say G of phi is 2. Now, how do I find G of phi in the beginning? Well, it's based on this initial equation. Is 0 to phi f of t dt. What that means is to find the area under the curve from here to here. So it basically is this triangle plus this trapezoid plus this triangle. You see? Now notice, and it's very easy. If let's take a look at this. This equation right here. If you look at these shapes, this triangle right here is a negative triangle with a negative area. It's possible to have negative area for this kind of graph. So negative area with a positive area from here to here. You see? So these two cancel out. Okay? So now we're only left with this part and this part. Now this is a negative area, and it will cancel out with this area because they're the same area except with the opposite sign. So all you have left is in the middle part right here is 1 for the bottom, for the base, and then the height 2 for the height. So 1 times 2, so it's 2. And that's where they come. That's where they get it. That's where they get g of phi equal to 2. So the question is, what's g of 10? Well, g of 10 is going from 0 to 10, f of t dt. Now notice, if it's repeating and it's the area under the curve, when that continues, so imagine, when this continue on like this, like that, right? You see? So this is 10 right here. So if the area under the curve from 0 to phi is 2, and then from phi to 10 is another 2, it just simply means it's 2 times g of phi, because it's a periodic function. So we got 2 times 2 equal to 4. Okay? So we got one answer right here. Given that g of phi equal to 2, find g of 10. Now we also need to write an equation for the line tangent to the graph at g at x equal to 108. Now that's a little tricky. Line tangent. You remember, anytime we're talking about line tangent line, we're talking about, this is what we need. We need a point, and we need a slope. Okay, so the point that we need is that we need to have 108 and g of 108. So that's going to be a little tricky, right? G of 108. So we need to find that. So that this answer here, well, in order to find the answer for g of 108, we then had to go back and use the same concept that we discovered over here. Slope, on the other hand, is g prime of 108. Now g prime of 108 just simply means f of 108. So then we had to then look at the graph and deduce what would be the value of the f at 108. So we had two different jobs here. We had to find out what this is, and we had to find out what this is. You see? So let's start with g of 108. Now g of 108 simply means integral 0 to 108 f of t dt. Now from 0 to 108, it means that it repeats the pattern of this pattern, repeating this pattern. How many times? Well, it means it repeats this pattern 21 times, right? 21 times for this pattern to occur, plus, or 21 times multiplied by 5, right? You get 105. 105. But then you want to do 108. So 105 to 108, you only have 3 left, 3 units left. And if you look at the original graph, this is every 5. So you do this every 5 for 21 times, you end up with 105. But then you end up with 3 more, 106, 107, 108. So then you will have to add to this portion, and then this portion right here. Now we know that 21 times this portion we already found earlier, which is 2. And then we need to figure out what this portion is. And this portion, notice, from here to here, they cancel out. And this one is 1 right here, this one is 2 right here, 1 times 2 is 2. So we get 42 plus 2, which gives us 44. Okay? Now, we also need to find, so that gives us g of 108, which is 44. So now we have a point. The point that we use is going to be 108 and 44 for x and g of x. You see, so that's the point. That's the point that we need to use to build the equation of the tangent line. Now we also need to figure out the slope. So slope is g prime of 108, which is f of 108. And now f of 108, notice for every phi we're going to do this 21 times, and eventually it comes to here. It becomes 21 times we get 105, 106, 107, 108. 108 will take on the same y value as x equal to 3. So we get 2. So the answer is for g prime of 108, which is f of 108, is equal to 2. So that's the slope. So what's the equation of the tangent line? Well, remember the point slope form: y minus y1 equal to m times x minus x1. So y minus y1 is 44, is equal to 2 times x minus 108. I will simply just leave this as my answer without simplifying. And that's the equation of the tangent line. And here then concludes our problem solution for 2006, number 3.